Okay, so now we're going to start 10.8, which is on complex numbers. All right, complex numbers are, well, but we'll see what they are later, but these involve those imaginary numbers that up until now we've been ignoring. Right? We've been ignoring, but now we need to deal with them, right? We need to define clearly what is an imaginary number, and we'll see in a little bit where that's going to be useful. Okay, so it turns out to be the very next chapter, right? So when we get to chapter 11, we're going to need these imaginary numbers, right? Because they're going to be part of the answer. Okay, so what is an imaginary number? Remember, we talked about the square root of, let's say, -1, right? That this is not a real number. Okay, this is not a real number. And it's an imaginary number, and we're just going to give it a name, right? The name we're going to give it is, well, the letter I for imaginary, right? I for imaginary. Yeah, so that's the definition of I, right? And this is part of the reason why you never saw equations with i's in it, right? We never used I as an actual variable. Now, that's not to say that you can't, and in fact, some equations you will use I as a variable, but generally not, okay? And the reason is because we're going to use I to represent this particular number, right? So I is a number, but it's not a real number, it's an imaginary number, right? It's the square root of -1. So this is just the definition of I. Now, what can you do? You can actually take the I and treat it as a number. Oops, sorry, I'm getting ahead of myself here. This I being the square root of -1. We can actually square both sides, just like we did in the previous section. And when you square both sides, that gets rid of the square root. And if you get rid of the square root here, this is just -1. So even though I is imaginary, it's an imaginary number, it turns out that when you square it, you get -1. And -1 is not an imaginary number. -1 is a real number. Okay, so even though I itself is imaginary, I squared is real. I squared is just -1. Okay, so we're not going to do a whole lot with these. It's basically just manipulating numbers that are imaginary. And in particular, let's look at the following example. I guess I'll call this example 1. And so we want to simplify. How about the square root of -9? What's the square root of -9? Well, it's an imaginary number because it's the square root, right? Even index of a negative number. And that's when you get imaginary numbers. Okay. Now, it turns out that you can think of this as the square root of 9, right, times -1. Right? So 9 times -1, of course, is -9. No problem there. Now, you are allowed to split up the two square roots. You can think of this as the square root of 9 times the square root of -1. However, you have to be careful because this rule, when you're dealing with imaginary numbers, this might not work. But it happens to work here. It happens to work very nicely here. Because the square root of 9 is just 3, and the square root of -1, well, we know what that is, right? That's the square root of -1 up here. That's I. So I'm just going to change this square root of -1 to make it the letter I. And so this is really just 3 times I. So, yep, the square root of -9 is really just 3I. Makes sense? Let's try another one. Let's simplify. How about the square root of -20? Well, first thing to do is break it up with the positive part, +20 times -1. So you get the square root of 20 times the square root of -1. Now the square root of -1, right, that's just I. But what about the square root of 20? How do you simplify that, right? So remember 20 is 2 times 10, but we're looking for perfect squares. So how about 4 times 5? So by breaking this apart, we can break it up as the square root of 4 times the square root of 5. And we did that because we can simplify square root of 4 as just 2 times the square root of 5 times I. Okay, so that's the square root of -20. It's going to be an imaginary number. That's the I part here. Now, you could leave it like this, but right, just like if this were an x, you would bring that in front. I would bring the I in front. I would write this as 2 times I. Sorry, I know my I's look like C's sometimes. So this is an I here. And then the square root of 5 afterwards. Okay, so I would write it like that. If you write it the other way, just make sure you're not sloppy, right? Make sure you don't do this. The I is not under the square root, right? So that would be wrong. So if you're going to write it this way, at least make sure the I is clear from the square root of 5. So again, I would accept this, right? Or this. Right. I just wrote it again here. But you should, in general, bring the I in front. And in particular, if you're sloppy and you put the square root over the I, then it's wrong. It's not the same thing. Okay. All right, so that's how to simplify square roots of negative numbers in terms of I. You always want to write it in terms of I here, right? Obviously, if this were the square root of +20, then there's no I, right? Because it's a positive square root, or it's the square root of a positive number, right? But you can still simplify it as the square root of 4 times the square root of 5. So it would be 2 times the square root of 5, but without this I here, right? Okay. Because, right, again, there's no negative inside the square roots. So, right. And in fact, we should make that clear, right? That's the difference between, I'm looking for this. Yeah, that's the difference between, right, the square root of -9 and negative square root of 9, right? These are not the same. We know what the square root of -9 is. We did it here, right? This is equal to 3 times I. And we know what the negative square root of 9 is, right? The negative square root of 9 is just -3. But -3 is not the same thing as 3 times I. They're two very different numbers, right? One of them is imaginary, right? A positive imaginary. The other is a negative real number. So they're as different as night and day, right? Imaginary and real numbers are just two very different things. Okay. So let's go on to complex numbers, right? So it turns out that you can take a real number, like 7, and you can add that to an imaginary number like 2i. Right? And when you do this, you form what's called a complex number. Right? So a complex number is built from a real number, the 7, and the imaginary number, the 2i. Right? So in general, your complex numbers look like this. You have a plus b times I. Okay, right. A is the real part, and the bi, that's the imaginary part. Okay, but you can't combine them, right? You can't combine real and imaginary. So if you're thinking this is 9 something, it's not, right? Because it's like 7 plus 2x, right? These are two unlike terms, right? So this is not 9x. Sure, if you have 7x plus 2x, that's 9x. And even though we're not going to do it, it turns out if you have 7i plus 2i, yep, you can write that as 9i. This is something you're going to get to in college algebra. If you take college algebra, this is something you're going to have to do pretty early on. but we're not going to worry about that here, right? For our purposes, right, the 7 does not have an I, so that's real. The 2I is imaginary. You cannot combine them, right? You can combine 2 imaginary numbers and 2 real numbers, but you cannot combine 1 real and 1 imaginary. You just leave it alone, just like you would here with the 7 plus 2x, right? Okay. Okay, so I think we'll do one more example. And this is going to come in useful for chapter 11. We want to simplify this expression here. 12 minus the square root of negative 192 all divided by 4. Okay, so how do we simplify this kind of a thing here? Right. So there are a couple of issues here that you have to be very careful of. You see a negative on the outside and a negative on the inside. And you can't cancel those. It's not a negative times a negative, right? Remember, when you have a negative on the inside, this is going to be imaginary, right? So you're taking a real minus an imaginary, okay? So you can't do anything with the negatives, at least not yet. The other thing you want to be careful of is that you don't go directly to 12 divided by 4 is 3. You can't do that yet, right? What you could do is split this up. You could do 12 divided by 4, right, minus the square root of negative 192 divided by 4 as well. But if you cancel them here, you're not going to have the 4 underneath here. So be very careful of that. I'm tempted to do that. Well, okay, but again, that's not the way to do this here. I think the way we want to go about this is as follows. We want to simplify the square root of negative 192. Well, okay, I'll do it here. So remember, just like we did up here, way back here, right, square root of negative 20, we had a positive 20 and a negative 1. So same thing here, we're going to have a positive 192 times negative 1. And now we can break apart the positive square root of 192 and then the square root of negative 1. Now, can we simplify the square root of 192? Yes, I'm going to do that down here. 192 is, well, I know it's 2 times something. If you divide by 2, you get 96. But if you divide by 2 again, you get 48. And if you divide that by 4, I think you get 12. So you can divide by a lot of 4s here. In fact, I think the easiest way is just to divide by 3. So if you divide by 3, if you divide by 3, you get 64. So 192 is 3 times 64. And remember, 64 is a perfect square, right? It's 8 times 8. So we don't have to go any further here. I think the best way to do this is to write it as the square root of 64 times the square root of 3 times the square root of negative 1 all over 4. Right, so you see where this is going. Square root of 64 is just 8. Square root of negative 1 is I. All right. And what else can we do? Well, we could put the I in front. Remember, that's a good idea. Put the I in, sorry, not a C, it's an I. My tails are a little big here. There we go. I times the square root of 3, all over 4. Okay. So now we could split this up. And I was going to do that way over here, right? And now maybe is a good time to do that. 12 divided by 4 minus 8I square root of 3 divided by 4, right? So 12 divided by 4 is 3. And 8 divided by 4 is 2, but we still have the I square root of 3 here. So there's our answer. Let me clean it up a little bit here. This is 3 minus 2I. Sorry, not a C. It's an I. And then times the square root of 3. Okay, so just to remind you where that came from, we were trying to simplify the number 12 minus the square root of negative 192 all divided by 4. And when you simplify that, you get this. right? Which is an imaginary number. In fact, it's a complex number, right? We have a plus bi, where the a is 3, and the b is the negative 2 square root of 3, right? The b does not include the I. The b multiplies I, right? So yes, so this is a complex number. And yeah, it's just equivalent to this, but this is the simplified version. Make sense? So yeah, you always want to simplify your answers. So when you see something this complicated up here, right, you want to simplify it until you get to this, which is, I think, the simplest possible way to write it. And that takes care of complex numbers. I think I should say one more thing about imaginary numbers. Again, a lot of you are thinking, well, if they're imaginary, who cares? And I talked about that a little bit in 10.1. It turns out imaginary numbers are actually very, very useful. But you're probably not going to encounter them in your real life, in your daily lives. After all, when you go to the ATM and you withdraw, $20, you're not going to withdraw $20 right? So, right, 20 times I is an imaginary number, and most of you have not seen imaginary numbers until recently. So yeah, in sort of your daily lives, imaginary numbers are obviously not going to come up. They're not really that important. But in science and engineering, these numbers come up all the time. And it turns out that they are actually very useful. But, unless you pursue either math or physics or, some form of engineering, you're not likely to see them again. So why do we bother with them? Well, we are going to see them again in the next section, in the next chapter. In chapter 11, these imaginary numbers will come up. Okay? And when they do, we have to be able to deal with them, and in particular simplify things like this until we get to, a plus bi, until we get to the basic imaginary numbers, right? The complex number here, a plus bi. So that's what we're going to do with them, right? So I'll leave it to the scientists and engineers to deal with imaginary numbers because they are very useful. In some sense, the term imaginary is really a misnomer. They really shouldn't be called imaginary numbers. They should be, someone I think coined the term lateral numbers. But whatever you call them, real, imaginary, whatever, imaginary numbers, they're just numbers. They're just a different type of number, one that you're not used to dealing with. But for the next few sections, you are going to have to deal with them. So sorry about that.